All right, guys, let's work on this one. So the last time I recorded 3.6, the chain rule definition and example 1, but I failed to upload it. So, sorry, Sabina. So what's gonna happen is I'm just gonna record it from beginning, okay? So I'm just gonna erase. Okay, so I'm just gonna erase the whole thing and start over, just in case if Sabina was absent, or if any one of us is absent, or if any one of us just want to listen to my voice again, you can. Yay! Okay, I'm so sarcastic. Okay, chain rule definition is the derivative. Okay, if you have a composition of functions, so f composed with g of x. So let's talk about the inner component. So this is the outer component. This whole thing right here is inner component with respect to x. So when you take the derivative, so the derivative of that is f prime, and I'm using this as a prime notation, okay, of the inner component still, okay, times g prime, so the derivative of the inner, okay. So what I'm saying is that, hey, you are taking the derivative of the outer times the derivative of the inner. Okay, so let's put it to use. This right here is the outer. This whole thing right here is the inner, okay? So when I go y prime, I can go, hey, outer, which is sine prime of the inner, which is still 7 minus 5x. I'm just writing it down right now. I haven't done any derivative. I'm just kind of copying out the formula. Then times the derivative of the inner. Well, the inner is this piece, and I'm about to take the derivative. Okay, so that's what it means. We can also use U system as well. So the derivative of sine is what? Cosine, right? And then bring this down. So now sine, the derivative sine of 7 minus 5x is cosine of 7 minus 5 times the derivative of 7 is 0. The derivative of negative 5x is negative 5. And we want to make this really pretty. So we're going to move the negative 5 in the front. So now we have negative 5 cosine of 7 minus 5x. And that's the answer. Now, what would this look like if I were to use u? So we can go u equals 7 minus 5x. That means u prime is negative 5. And I can write y equals sine of u, right? Well, here's the tricky part. When you do y prime, then you have to do sine prime of u times u prime. Okay, so this is the part where, because u is the inner. Okay, so keep that in mind. U is the inner component. So you have to do the derivative of the outer times the inner, the derivative of the inner. So what is sine prime of u? Well, sine prime of u is cosine of u. What's u prime? Well, u prime is u prime because we don't know what it is. Well, now we can plug it in, right? So what is u? U is cosine of 7 minus 5x, and u is negative 5. And so u prime is negative 5, and make it pretty. And as you can see, either way is exactly the same. Okay. Okay, so let's try 2. Take the derivative with respect to x. Y equals tangent of 2x minus x to the third. So for this one, you can do u substitution, or you can just do the inner and outer. So based on our inner and outer component, y prime equals, outer is tangent. So I'm going to go tangent, and I'm going to use this black thing as the derivative because I don't want it to look like a power of 1, okay? So the derivative of the outer, copy it down, okay? So that's, this whole thing's inner, times the inner derivative, Okay, and I haven't done any derivative yet. I'm just copying down the definition. Well, what is the derivative of tangent? The derivative of tangent is secant square. Okay, and then bring down the inner component. Well, now I have to do the derivative of this inner in the back. So the derivative of 2x is 2. The derivative of negative x to the third is minus 3x squared. And normally we don't put things behind the trig function, so we will move this to the front just to make it pretty. Times secant square of 2x minus x to the third and box out it. Okay. This chain rule seems easy, but it's really difficult, so make sure we practice a lot. I don't give you a lot of homework for 3.5 or 3.6, so make sure you go and practice extra questions, okay? Let's practice some more on number 3. So now you have a couple of different things, okay? So let's slowly, you're gonna need to do this slowly and carefully, okay? I'm going to, let's think about this. Take the derivative of sine of x all over 1 plus cosine of x squared. So let's use u right now, so that way it's not confusing, okay? So let u be sine of x divided by 1 plus cosine of x, okay? So u prime, you're going to need to do a lot of work because this is a quotient rule that we have to use. So here we go. U prime equals the derivative of this, derivative of sine x times the denominator, minus the derivative of the denominator times the numerator, which is sine of x, all over, this is just u, we haven't done y at all, okay? All over 1 plus cosine of x squared. Then from here, we need to simplify. The derivative of sine is cosine of x, and bring down the 1 plus cosine of x here, minus the derivative of 1 is 0, the derivative of cosine of x is negative sine of x, times the back, which is sine of x, all over 1 plus cosine of x, and then square outside, okay? And again, this is still just u, okay? So keep that in mind. And if I'm going too fast, feel free to ask me to pause it. So from here, I will distribute. So cosine of x times 1 is cosine of x. Cosine of x times cosine of x is going to be cosine square of x. A negative times a negative is a positive sine square of x all over 1 plus cosine quantity square. Okay. From here, would you agree that this is going to give me 1? So if that's going to give me 1, then I now have 1 plus cosine of x all over 1 plus cosine quantity square. Ooh, it cancels, doesn't it? So this is going to give me 1 over 1 plus cosine x. Okay. Now that's not the answer. That is just what? U prime. Okay. So what do I do here? Well, I have to really find the derivative of y. But keep in mind, y is u squared. Remember that? Because this whole thing right here was u. So y prime is 2u times u prime. Okay. So from here, I would have 2. U is that whole thing, sine of x over 1 plus cosine of x. Okay, that's u. U prime is 1 over 1 plus cosine of x. That's what u prime is. Then from here, we can multiply it out. So multiply across, 2 times sine times 1 is 2 sine of x, On the bottom, I'm not going to distribute that. I'm just going to leave it as is, because as you can see, even when I distribute, it's not going to make it any prettier. So this right here is the final answer to your question here. Okay, so keep that in mind. This one, it's a lot more difficult, so that's why. Now, the question that most of us will come up with is this right here. Okay, so y equals u squared. Oh, pink, yuck. Y equals u squared. It's, okay, so the derivative of that is y prime is 2u, that is 2, but I also need to multiply by u prime, okay? So I want you to understand that, okay? Because remember, the derivative of y is y. The derivative of x is 1 only because we are taking with respect to x. The derivative of u is u prime because it is not with respect to x, okay? So I want you to understand that really well. All right, example 4. Find the derivative for y equals cosecant of x plus cotangent of x to the power of -1. And again, I'm just going to use, this time, you can use u substitution or you can just do it straight, right? So if you do it straight, here's what it looks like. Y prime, because I used u substitution in example 3, you don't have to use u substitution. You can just do the power rule. Here we go. The derivative of y prime is you bring down the power, okay? Then you are going now to copy the inner component and subtract the power. -1 minus 1 is now -2. But you still need to multiply the derivative of the inner component, okay? So, what does this look like? Slowly and surely, let's work it out. Okay, well, let's continue to simplify and cautiously. Because this has a negative power of 2, I'm just going to write it on the bottom and make it a positive power of 2, like that, okay? Now I would have to work out the derivative of cosecant of x plus cotangent of x carefully, okay? Now let's work out just the derivative of cosecant of x. Can someone tell me the derivative of cosecant of x? Flip back, look at the definition of the derivative of trig values, and let me know what is the derivative. And while you're on that, why don't you tell me the derivative of cotangent of x as well? Okay, so hopefully you wrote down the quantity here. Okay, the derivative of cosecant of x is negative cosecant of x times cotangent of x, right? Plus the derivative of cotangent of x is negative cosecant square of x, okay? So that's the derivative of those. Now, from here, we have to simplify, okay? So slowly and cautiously simplify this out. What do you think we need to do? Okay, well, let's multiply across, okay? Because -1 times this, because this is pretty much over 1, okay? So -1 times that is now positive cosecant of x, cotangent of x. -1 times that is, again, positive, so positive cosecant square of x all over. And then the denominator, we will keep it just like that for now to see what happens. Okay, what do you think we need to do next? Can we factor out cosecant of x? Of course we can. Factor out cosecant of x. you now are left with cotangent of x plus cosecant of x all over cosecant of x plus cotangent of x squared. What do you want to do next? Can we cancel? Of course we can. And then there's one left, right? So from here, we have cosecant of x all over cosecant of x plus cotangent of x. Now what do you want to do? Should we convert to sine and cosine? Of course we should, okay? Cosecant of x is 1 over sine, okay, of x. And then I'm going to write division this way. Divide 1 over sine of x plus cosine of x over sine of x. And then from here, I'm going to write 1 over sine of x divided by, the denominators are both sine of x, so I'm going to put the numerator over it because you are dividing by a fraction, so I'm going to multiply by its reciprocal. When I multiply by its reciprocal, can you see what's happening? Yep, sine and sine's canceling. So the derivative of cosecant of x plus cotangent of x to the power of -1 is 1 over 1 plus cosine of x. Okay, so now if you think about this, this is example 4, and we did not use u substitution, okay? And in example 3, we use u substitution. The question to you is, hey, which one do you prefer? It doesn't really matter to me. I don't really have a preference of your method. You pick the style that you want to use, okay? Let's do example 5. Notice how these are just a lot of practice questions, okay? It's not, I'm just giving you a ton of them, so that way it looks easy, but it's really not, okay? So make sure you practice more if you need to, beyond the questions that I gave you on homework. Repeated use of the chain rule, okay? That means chain rule within chain rule, yay! So here we go. I'm going to do u substitution, okay? Let u be 1 plus 2, no, cosine of 2x. Okay, u prime with respect to x is going to be, derivative of 1 is 0. Derivative of cosine of x is negative sine of 2x. I'm sorry, derivative of cosine of 2x is negative sine of 2x times the inner. Remember, this is the inner, the derivative of the inner. So the derivative of the inner, okay? So u prime is negative sine of 2x times 2. That is the derivative of 2x. Let's make this pretty. So u prime is negative 2 times sine of 2x, okay? So let me highlight u prime. So u prime is this, and u is this, okay? So for our question, I'm going to now change it to y equals u squared, because I let the inner piece be u. So y prime is 2u times u prime, okay? And no, u prime is not 1. I want you to understand that. Repeat after me. U prime is not 1, okay? So from here, we're going to go substitute in what u was. And u was 1 plus cosine of 2x. U prime was negative 2 sine of 2x. Okay, ready? Let's distribute. So from here, we get 2 plus 2 cosine of 2x. That's the first. Minus 2 sine of 2x. Let's distribute some more. Then from here, those is now -4 sine of 2x. Would you agree? And then from here, I now have a -4 sine of 2x cosine of 2x, okay? Now let me bring back a couple of identities, okay? One of it is the double identity, double angle identity. Okay, so one of them I want to remind you is sine of 2 theta, or 2x, is 2 cosine of theta sine of theta. So what does it mean? Okay, what if I have sine of 4 theta? That means I have 2 cosine of 2 theta sine of 2 theta. That's what it means by that. So from here, and then what if I have sine of 6 theta? Okay, the pattern keeps on going, okay? So guess what? From here, you can think of it as -4 sine 2x. Not much we can do with that. But this one, I'm going to write this. 4 is 2 times 2. Sine of 2x cosine of 2x. Okay? Then would you agree that this fits in that double angle identity? Woo, right there. So from here, I would have -4 sine of 2x minus 2, what? Sine of 4x. Okay. And this is as simplest form as we can go, as far as we can go, because I can't combine these at all because they're different. One's a double angle and one's quadruple angle, so there's not much we can do. But that's as far as we can go. Someone can tell me, anybody, what is the identity if I have this? Fill that in. Can you see the pattern? I'll double check that next time. Okay. All right, last example of 3.6. Yay! And again, if this is going too fast, please do ask to pause. Okay, find the derivative again. So what I'm going to do is write this as a power function, because that tends to be a little bit easier for me. So tangent of 5x to the power of 1/2. Okay, we did use substitution above. We can totally just use power rule here, so that way we can switch back and forth. So y prime, bring down the power of 1/2 times the inner component, which is tangent of 5x. We subtract 1/2 power from 1, so now it's -1/2 times the inner component derivative, okay? So that's slowly working itself out. Then from here, what I would do is, because it's a negative power, I'm going to write it in the bottom, so make it positive power of 1/2. Okay, power of 1/2 is also square root. Then from here, I'm going to slowly take the derivative of tangent of 5x. Now, tangent of 5x, I do need to use a chain rule with that, so that's why this is a chain rule within a chain rule. Derivative of tangent is what? So what is the derivative of tangent? Did you say secant square? Yay! It is secant square of 5x times the inner component is 5x, so I have to do the derivative of that. See, notice we're doing the derivative of the derivative, right? So that's why this is so hard for some of us. Then from here, I'm going to copy this down, 1/2. If you want to write square root on here, this one, it's totally okay too, okay? No big deal. Okay, so 1/2 times square root of tangent of 5x times secant square of 5x. The derivative of 5x is now just 5, okay? And then you can put it all over 1. Now let's just simplify this. So not much you can do, really. So on the top, I would just have 5 secant square of 5x all over 2 times the square root of tangent of 5x. And that is as far as you can go. The key here that I want you to see is that notice how we're taking the derivative and the derivative again, so that's why it's called the chain rule of the chain rule, okay? All right, this is the end of our 7.6. Until next time.